Hello, welcome to day 5 of my advent of live coding and receiving your content. You'll see in a moment. Get ready. Blah 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 blah. The internet can totally see you now. That looks good. Okay, cool. So it is day 5, and things, I always get paranoid about sound not working, but I think it's working. So let's go to day 5. Alchemical reduction. Okay, so while it's still fresh in my head, let's do day 05 alchemical reduction.py. And let me zoom in a bit to make it better. Okay, good. You managed to sneak into the prototype suit manufacturing lab. I read this every day, and I haven't been following the plot. Sneaking into a lab, there was a guard who was sleeping, but I haven't been paying attention to the story, so I don't know what the story is. The elves are making decent progress, but are still struggling with the suit size reduction capabilities. While the latest in 1518 alchemical technology might have solved the problem, eventually you can do better. You scan the chemical composition and discovered that it is formed by extremely long polymers, one of which is available for puzzle input. Polymers formed by smaller units, which when triggered react with each other so that two adjacent units of the same type and opposite polarity are destroyed. Units types are represented by letters, units polarity is represented by capitalization. For instance, R and R are units of the same type, opposite polarity, whereas R and S are entirely different types and do not react. In A and A react, leave nothing behind. In A, B, B destroy itself, leaving AA. As above, this then destroy itself, leaving nothing. In AB, two adjacent units of the type, nothing happens. In AAB, no AA and A are the same type, they're placed match, nothing happens. Now consider a large example. DA blah blah blah. Remove a CC, that's good. This creates AA, which is removed. Either CC is removed, the result is the same. No further actions can be taken. After all possible reactions, the resulting polymer contains 10 units. How many units remain after fully reacting the polymer you scan? In this puzzle and others, the input is large. If you copy paste your input, make sure you get the whole thing. Okay, so this sounds pretty easy, I want to say. Okay, so let's go data day 05.txt, paste it, save it, close it, close it. And then finally, let's copy their test case. Okay, so we want to reduct. I'll call it reduct, even though that's not a word. Def reduct a polymer, which is a string, and it's going to return a string. Pass, and then what I want to do is I want to assert that if I reduct that test case, that I get this thing. Okay, so that's fair enough, and no one has pointed out anything good. So now how do we reduct this thing? All we need to do is so let's think about this. So let's call this reduct1, and so this will just make one pass. Actually, let's just start here. So what I want is while true, let's just think about this. Okay, so what I want to do is to say for I in range 1 then polymer. If, and what do we want to call this? So let's say same type S1 string and S2 string, and that's going to be a bool. So they're the same type if they're the same. Return S1.lower equals S2.lower. So if they have the same lowercase, they're the same type. That's not the only way to do that, but A and A are the same type. And so that's one easy way to do that. And then we want we'll cheat. And so for I in range 1, let's say what do we call these? Unit 1 equals polymer I. Unit 2 equals polymer. Actually, let me call this I minus 1. So we'll get polymer 0, polymer 1, then polymer whatever. And if same type unit 1 and unit 2, and unit 1 not equal to unit 2, so this isn't the best way to do this, but basically I'm saying if if you lowercase something the same but they're not the same, that means one's the uppercase and one's the lowercase. I mean, they could be longer strings, so that wouldn't work, but this will work. Then I get rid of them, right? So polymer equals polymer up to I minus 1 plus polymer I plus 1 up to the end. So I just remove those two pieces, and then I break out of the for loop, right? And what I really want to do is I want to do was able to reduce equals true, and then I'll say while was able to, I'll just say did reduce equals true. So while I did reduce, and then I'll set did reduce equal to false, and this will allow us to figure out if we made any progress on this one loop. So for I in that unit that did reduce equals true, and then break out of this for loop. And so what's going to happen is, so I feed it in this thing. It's going to say did reduce equals true. So I go into this loop, and then I'm just going to go through. And when I get to basically this capital C here, I'll get unit 1 is little c, unit 2 is big C. I'll get the same type, and they're not equal, so that's good. So I'll go polymer up to DABA, and then polymer after, and then I'll say I did reduce, so go through another round. And so I think that's simple enough. Let's run that test case. Day 05. Chemical reduction unit is not unit 1, not unit. Okay. So it didn't work. And it didn't work because I did not return the final polymer. So let's run it again, and now it worked. And they gave me a couple more examples, so let's just do this. Assert reduct of AA is that, and then assert, same with this one, of reduct of that also is empty, and then this one nothing happens. So let's say assert reduct of that is just itself, and then here we have again where nothing happens. So assert reduct of this guy is himself, and let me just stick this literally into himself. Okay, so now let's run it again with all those test cases, and so that seems to be good. So let us with open data day05.text as f polymer equals f.read.strip. So we'll read it and we'll strip it, and then we went to print reduct polymer, and now let's run it. It's sure taking a long time. And it's taking a long time because, why is it taking a long time? It shouldn't take that long. Because there's 50,000 characters. So maybe what I want to do is, I'm sure what they're doing is, they probably stuck all the ones at the end, so it's looping all the way through. So like, if I look here, there's MM and a bunch of XXs. No, actually, so let's just print the length of the polymer and see how that proceeds. Yeah, it's just going. Just gotta watch it. It's probably a faster way, but I guess it's not really worth my while to figure it out. So we'll just sit here and make sure that I haven't missed anything. How many units remain? Oh, and I should have, that's what I wanted to print anyway, so it was probably bad for me to print the whole thing. So, but really, looks, okay, so, and let me make sure that I printed it after every time I reduced it, which I did. So that means that 10766 is probably right. That is the right answer. Okay, good. 1 gold star closer to fixing the time stream. Time to improve the polymer. One of the unit types is causing problems. It's preventing the polymer from collapsing as much as it should. Let's figure out which unit type is causing the most problems, remove all instances of it, fully react the remaining polymer, and measure its length. For example, again, using the polymer from above, removing all AA units produces this, fully reacting the polymer produces that, all BB units does that. So what is the length of the shortest? Okay, so that's going to take, 26 times as long, which is long. So it really behooves us to figure out how to make this faster. So let's figure out how to make this faster. And to do that, let's figure out why it's slow. So we're just iterating 50,000 times. That's, this is cheap, this is cheap. This is, same type should be cheap. Okay, so doing this string concatenation is not so cheap. So let's think about a faster way, because that's what's, every time I do that, it's O of n. So that itself is another 50,000. So let's think about how to make that faster. And we can make that faster by, let's change this to print the length of the reduct of the polymer. for starters, let's not work with string. So let's say units equals list of polymers. So that's a list of characters. And let's say deleted is a set. So we're just going to keep track of which ones we've deleted. So for I in range 1 to len polymer, so let me take that for loop. And so what I want to say is low equals 0. No, so what I want to do is I want to say for low in range len polymer. Why am I having trouble with this? I'm having trouble with this. I'm tired, but this shouldn't be really hard. So what I want to do is I want to say all the indexes equals I for I in range len units, and I want to keep track of the ones I deleted. And so now what I want to do is the following. I want to let's say previously equals for I in indexes if I not in deleted break. So this is get first non-deleted index, and then for j in so let's think about this. I'm having a lot of trouble with this, and I shouldn't be because it's not that hard. But okay, so let's think about this. So what I want to do is I want to say 0, 1, 2, 3, whatever. And now I want to go through and say, oh, you know what, 2 and 3 are done, so I'm just going to wipe those out. And now I just want to go through the list again. So let's say next index, and let's say prev index int, and this will go to an int. And so what I want to do is I want to say for index in range, and I want to start at the previous index plus 1, and then length of the units. If index not in deleted, return index, and then otherwise I'm here, and I want to return len of units, which will be so let's say low equals next index minus 1, and let's say high equals next index from low. So now I have this, and let's say while high is less than length of the units. So what do I want to do? I want to say unit 1 equals units low, unit 2 equals units high. If unit 1 dot lower equals unit 2 dot lower, and unit 1 not equal to unit 2, then I'm going to do the following things. I want to say deleted dot add low, deleted dot add high. So I want to delete both of these, and now I want to say low equals the next index after high, and high equals the next index after low. And then what I want to do is I want to say return, I want to join it into a string now. So let's say unit for I, unit in enumerate units, if I not in deleted. Okay, so that might work and that might not work. So to start with, let's run that, and my unit tests seem to have passed at least. Let's no, they didn't pass. It's just stuck. And why is it stuck? Because this is otherwise low equals high, high equals next index after low. Okay, so let's say reduct ABBA is AA, and that's because I didn't put it in a while loop. Did reduct equals true, while did reduct did reduct equals false, and now do this, and did reduct equals true, but also let us keep going through the list, because why not, right? So now let's run it again, and now those all pass, which is good. And so now let's do this, and let's just print len units minus len deleted, and it's possible this isn't. Why shouldn't it start at 50,000? It did start at 50,000, and it just made a huge pass the first time through, which is good, but it's actually doesn't seem 118, 117, 116, 115, 114, 113. Doesn't seem faster at all. No, actually that was quite a bit faster. 10766. Was that the right answer? I can't remember now. Anyway. Does it tell me what my right answer was? It probably doesn't tell. 10766. So that is correct. Okay, good. So now what I want to do is I want to say cars equals C dot lower for C in polymer. So let's do that. Okay. So, and let's say best equals that. So for C in cars, polymer no C equals polymer dot replace dot replace like that, right? Polymer no C equals polymer dot replace, and let's make sure we're trying to copy. Yeah. Dot replace C that dot replace C dot upper that. So let's now print C. And best C equals len reduct polymer no C. So this might take a while. Let's see how long it takes. I don't want to print all those things. I need to. So let's comment that out, and let's remove that, and now let's run it. This is taking absolutely forever, which stinks. So let's go back and think about actually it's not taking that long. That's 4 out of 26, so that's like 1/6 done. Five. So let's go and think about how we could have made this faster, because I feel like it should still be able to be made faster. So I go through and I wipe this out, and that's fine. And I go through and I wipe this out, that's fine. And I go through and I wipe this out, and that's fine. And maybe it's just like a n squared problem. Like I have 50,000 characters, and in order to do this, I need to go through it so many times, and it's just 50,000 times 50,000, and there's not much around it. But that means we're stuck waiting on the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so it's halfway done. So you just take the string's input, return the number of letters remaining after reactions. Yes. In the second part, they want you to check for each length of short following groups from all units one time floating to the unit, right? Or they say, maybe if you removed all the D's and then ran the algorithm, you'd get something even shorter. Try every letter, and what's the shortest you can get? So let's see, I should print a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, we're getting close, 21. So I hope this works. If it doesn't work, then it's another, couple minutes letting this run after we figure out what's wrong, and let's fix it. But we also need to say we'll best key equals min, best key equals lambda c best c, and print best key. Let's print best. So once this goes, I feel like this is about 26 letters, so we should be pretty close. Okay, so best. So the best key is clearly P because that gets you down to like 6,000. And so they don't want the letter, they want what is the length of the shortest polymer you can produce. So that looks like 6538. So let's put in 6538. And that's pretty clearly the best. That is the right answer. You're 1 gold star closer to fixing the stream. So return to the calendar, and that's done. So yeah, so that worked. It wasn't really that great. It didn't feel that great anyway. Git add data, git add day 05, git commit, day 05, yuck. Regex faster for what? For getting rid of the characters? I don't think that would be any faster. Maybe that's not the bottleneck. I don't think. All right. So that's it. And yeah, so that was, like I said, that was not the best, but maybe tomorrow will be better. So follow me on Twitter. You found me on YouTube already, and make sure to don't make sure if you want, check out the Patreon. That's up to you. Yeah, so that's it, and I'll see you tomorrow.